So, one of the biggest parts of week one was learning about the parts of being able to write electron configurations. So, why do we put in all that effort only to kind of maybe talk about it later? Well, because it's coming back this week. It turns out that the numbers of valence electrons that an atom has determines how many bonds it can make. Dyes and fibers are organic molecules that are made up of carbon, hydrogen, nitrogen, oxygen, and sulfur, and some phosphorus too. So, understanding how these elements come together to make bonds, and then by extension, the structure, or as complicated structures of molecules, will inform us of how these molecules are formed. And if we know their structure, then we can know their function. But before we get there, we've got to learn the ground rules of writing structures called Lewis structures, which we'll do this week. Even though we've learned that metals can make covalent bonds, they tend to follow their own rules of bonding. So when we go through and draw structures, we need to keep in mind that we'll only be working with nonmetals. So this week, we'll review how many valence electrons each family has and how many bonds they'll make as a result. We'll learn what happens when electrons aren't perfectly evenly shared between atoms and bonds. Then we'll go over how to write the structures of molecules, followed by learning about a method to check our proposed structures. You'll notice